Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Symmetry by Mello Robinson. And here are the rules. We have chaos construction rules, where we need to divide the grid into 9 regions of 9 orthogonally connected cells, and fill every cell with a digit from 1 through 9, so that there aren't repeats in any row, column, or region. Now, what is an orthogonally connected region? It means that it's a region where you can go from any cell in that region to any other cell in the region just by going through edges, all while staying within the region. So, for example, to get from here to here, you can go from along these edges while staying within the region. So that's why this is a valid orthogonally connected region, because you can do that for every 2 cells in the region. What you cannot do, though, as a valid orthogonally connected region is have something like this, because these 2 cells, even though they can get to each other by going through edges while staying within the region, they cannot go to the other cells in the regions by going through edges while staying within the region. They either have to go through a corner or go through an edge, but exit the region to do so, and neither of those are allowed. So those are examples of how orthogonally connected regions work. The next rule is internal xsums, where the digit on a circle clue indicates how many cells of its region the circle sees in all orthogonal directions, which means just horizontally and vertically, including itself where region borders block vision. So, for example, this would see only 2 cells because it's blocked by the borders here, so it cannot see these cells here. So this would have to be a 2 for this digit in the circle. And if a clue has a number attached, all the seen cells must sum to it, including the digit in the circle, and all possible circles are given. So, for example, if this were a 2 here, this would have to be 8, because the total, these, if this were the valid, if this is a valid region, then this would only see 2 cells, so it would have to be 2, and these 2 cells must add up to 10. And therefore, this must be 2 and 8 to add up to 10 for that to work. And keep in mind you have the negative constraint there too, where all possible circles are given. So that, for example, this cannot be a 5 because it sees 5 cells, and if it does see 5 cells, all possible circles must be given. So it would have to have a circle around it for that to satisfy that. But since it doesn't, this can't be 5. Then that we know. So that's the negative constraint involved here. We have region mirror, where across the marked diagonal, the shapes of the regions are mirrored exactly. And this includes regions on the diagonal, which must be self-symmetric. So, if we had a region going this way, we would symmetrically also have to have a region going like this. So that around this central diagonal, everything is mirrored exactly. Interesting. And finally, we have nintropy mirror, where 2 cells reflected across the marked diagonal must be from the same nintropy, that is, be from the same set of 1, 8, 2, 7, 3, 6, 4, 5, or 9 by itself. So say this was a 2, this must be from the same set. So this could be 2 or 7. Oops. This could be 2 or 7 here. It's because of the nintropy mirror. This would have to be from 1 or 8 to match this cell here. So we'd have to have 1 or 8. 18 or sorry, this cell would have to match that cell for the entropy, right? So that's how nitropy mirror works. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. To add up to 38, we are going to have to see at least 6 cells. Because 5 cells at minimum adds up to 35. But we cannot have 9 cells. So this has to be a 6, 7, or 8 here. And by the nitropy mirror, this could also be 6, 7, or 8, but it could also be 1, 2, or 3 there. So this must see 6 cells of its region. 10 can see up to 4, 1 through 4. So this is corresponding to 1 through 4 here, or 5 through 8 by the nitropy mirror. This 18 can be the sum of 5 unique digits at minimum. Sorry, at most. What's the most it could... Sorry, what's the minimum it could be? It could be 3. It could be 4, and it could be 5 at most. So this is 3, 4, or 5. This must be 3, 4, 5, or 6. Okay. And 34... To add up to 34 has to be at least, it can't be 5 digits. 5 digits, you can't have 5 digits add up to 34 as long as they're unique, which they would have to be for the sum, because they are in the same region. And because you can't, 5, 6, 7, 8, 9 adds up to 35. 4, 5, 7, 8, 9 adds up to 33. And those are the only possibilities around 34. So this can't be 5. It could be 6. It could be 7. It cannot be 8. Because that means the remaining digit in the region would have to be 11. Because 45 minus 34 would be 11. So this could be 6 or 7 cells here. Okay. Let's draw a border around the entire grid for now. It must be symmetric, though. If it must be symmetric, how do you see 6 cells? Because it must see the same cells going this way as it does this way, and it must see the same cells going this way as it does this way. So doesn't that mean it has to be 7? Yeah, I think that means this has to be 7, which means this cannot be 7 here. So this sees 7 cells. That means it can see at most 2 cells here. It sees a third here, and then 4, 5. It has to see these 5 guaranteed. So those are all the same region. It could see either those 2 or these 2. We're not sure which. So this... So this must be symmetric around this region. If it goes this way, that means this is part of that same region. And so then these would have to still be symmetric around the diagonal, so it has to go there. And then this would see 1, 2, 3, 4, 5 regions, or 5 cells. How about if it goes this way? If it goes this way, could be 4 still. Sorry, could be 5 still, because it could go there, No, it can't. It can't go here and then here, or then here and then here to be symmetric. So it would have to be 4, I think. It can't close any of this off in that case. Can't extend further, but it could do something like this. So that is potentially possible. So this is 4 or 5 here. We're not sure which. The digits missing on this that this cell does not see. Oh, so this is 4 or 5, which means this has to be 4 or 5. So we're missing 2 digits adding up to 11. So it must be either 2, 9 or 3, 8 that we're missing. Interesting. Okay. Oh, and they have to be seen. They have to have their counterpart be symmetric there. So if we were missing 3, 8, we would have to have 1, 2, and 9 be seen by all of these cells. But that's not going to be symmetric, right? 7 has to be symmetric. The 2 has to be symmetric with the 7. And the 7's already accounted for here. So that means what must be seen then has to be missing a 2 and a 9. So the remaining digits are 1, 3, 6, and 8. And it could be 1, 3, 6, 8 here or here, or 1, 3, 6, 8 here or here. 2 and 9 are not going to be symmetric with anything else nitropy-wise. Because 2 is symmetric with the 7, 9 has to be symmetric with itself only. So that means we have to have 2 digits on the diagonals instead of 2 digits surrounding the diagonal. So therefore, it must be these 2. Because it can't be 2 and 2 here. Because this is going to go 4 that way and 4 that way. It has to be these are the 2 lights. And this has to be light and light here to connect orthogonally. So we have 1, 3, 6, 8 here, 1, 3, 6, 8 here. This is 2, 9 as a pair. So this is done as a region. For the light region. Oops. Okay, so we have to have one region going out this way. And then that matches that region going out that way. This can see at most 7 cells. But it's unlikely to. And in fact, if it tries to see 7 cells, the problem is this would have to see at least 7 cells, so it would have to see 8 cells. But then the cell that's missing would have the digit that's missing from the region that it doesn't see would be 7, but we'd have a 7 there, so this cannot be 7. This sees 3 through 6 here, potentially. But this can't see 6 cells either, because then that would see 6 cells here. So this must be 3 through 5 here as possibilities. And this must be the nitropene mirror. So it could be 3, 4, 5, or 6 to be there. What else do we... Oh, this sees 5 cells? 1, 2, 3, 4, 5. Yep. So this sees 5, that sees 4. Um, oh, this cannot be the same digit as this. And the reason why is if it's the same digit, they would see the same amount of um, cells in the region, right? Because it's a region mirror. Oh, that's interesting. So this is 1, 2, 3, 4, which means this cannot be the same as that digit there. Because same with this. This can't be the same as that digit because the regions have to be exactly mirrored, and if it's the exact same digit, it has to see the exact same number of cells. That's that's very cool, actually. That is very cool. So we know this can't be 6, 7, or 8, and we know this can't be 1, 2, 3, or 4. 7 here means this can't be 2 here. You can't have 1. You can never see 1 cell. So this can't be 8. So this sees 3 or 4 cells adding up to 10. So yeah, the digits in a circle can never be 1 because you have to orthogonally connect to the rest of the region, which means that you necessarily have to see 2 cells in the region. Right. This must be the opposite here. So it's 4, 5, or 6. This is 4, 5, or 6. That's kind of cool, actually, about the way that those circles work. It's specifically the region mirror, which makes it work that way. So, pretty clever. Um, um, these could be in the same region. Oh, this cannot see 6 cells or more going that way. So this must be part of the same region, which means these must be part of the same region. This cannot see more than 4 this way. So this would be at most 4 this way, which means it does have to go that way to form a region, because we see at most 4 here. That's 5 and 6 at least, so this must go that way, 5 and 6. This must see 3. It could see that way. No, it has to see more than that. This sees at most 4 that way, so then it must see 5 and 6 here. So that's part of the region. That's part of the region. So this cannot... Well, we already knew that was at least 3. This must see... This has to be the exact same as this. Because they see this... Well, it's not true. It could go in that way, potentially. So we see 5 here. We could see 6. Can we see 6 this way, though, is the question. If this is 6, this must be a 3, which would mean that's 4. I guess we could, with that being dark. Hmm. Hmm. We don't know what these are. Again, these have to be the opposite digits on the nintropy pairs, but we don't know which one it is. Hmm. Can this be 3 anymore? If it's 3, that means all of these are seeing. And it must add up to 18 at least. 3, 6, and 9 does kind of work. Okay, what can this digit be? It's at, obviously it can't be 4, because if it's 4, well, we have 4 in the row. It could be 3 here, and then we have, so if it's 4, this is 1, 2, or 3, guaranteed here. Which would make that 6, 7, or 8. Okay, but this cannot be 8 then. So 8 cannot be here, which means this can't be 1. It would be 2 or 3. No, this can't see more than this digit here. Oh, well, this still could be... Well, if this sees 8... 1, 2, 3, 4, 5, 6, 7, 8... This could see 6 or 7. Yeah, so that could work. This has to see less than that, though. So this can never be 6. Right? If this is 6, this sees... Well... It could be 6 and then this sees 7, maybe? It's kind of weird, but it's possible. So if this is 4, this is 1, 2, 3 as a set there. If this is 3, it would have to be 1, 3, and 6, or 2, 3, and 5 there. So that corresponds to 2 and 3 corresponds to, sorry, 5 and 6 corresponds to 4 and 3. And any of those are possible. It could be 3 that way, it could see 4, it's 6 that way. Okay. If this is 4, this would have to be 1, 2, 3 here. And then this would be 6 with 5, 7, 8. No, sorry, this would be 5 with 6, 7, 8 here. But how would that work? This would have to be 3 or 4. Okay, let's go through that scenario. If that's 4, this is... So this would be 4. You have 5 here. That would force us to be 1, 2, 3 here. No 4 here. It's 5 or 6. No 5 there. This is 6, 7, or 8. 6, 7, or 8 this way. This only sees 4 cells, so we'd have to go at least 2 that way. So this would be 2 going that way. We have 1, 2, 3, 4, 5, 6, 7, 8 cells in the region. So we only have 1 more available, which would be one of these 2. This would see then either 3 cells or 4 cells. So we'd have a 3, 4 pair there, which means this is a 5, 6 pair there. So either that's red or that's red, and that's dark or that's dark. So far that's okay. You could have 1, 2, or 9 here. 1, 2, or 9 here. This can't be 9. We see 38 here. So what are we missing? We're missing 3 digits, adding up to 7, which is 45 minus 38. So that would be 1, 2, and 4 missing. So this could not be 1 or 2 here. It would be 9. No 9 here. This could not be 4. We don't know that that's the case. But it's pretty likely, right? This can't be, this is 6, 7. This can't be 6, 7 as a pair. Therefore, this would be 8. This would have to be 1. No 1 there. This actually looks like it's working. So this adds up to 30. No, it adds up to 26. Okay. Yeah, I was hoping this would lead to a contradiction, but it's not. Might be the actual solution. Okay, what happens if it's just 3? If this is 3, this is not 3. We can't have 2 or 3 here. So this sees only 3. Oh, the 4 could actually even go here, though. Didn't realize that. If this is 3, this is 5 or 6. This has to be 6 for the 9 trippy mirror, which means this can't be 6. 7 or 8 with 1 or 2. That leaves this as 3 or 4. So that's not going to work. Okay, so yeah, that's a contradiction. So if we had 3 here, this only sees 3 cells this way, and it can't, therefore we have boundary here, boundary here. Therefore, this is boundary here. This must be a 6, but the problem is this is definitely boundary here, and this only sees 6 cells because of the boundary here at most. So that does not work, which means this has to be 4. So this has to be 4. There's no 5 or 6. This is 5 here. And it could be here, or it could be here that it sees, and that's what I forgot. It could have actually been here. 4 eliminates 4 here, so this can't be 5. This sees 3 or 4, so it could be seeing the same digit there. Maybe we can run into a contradiction there, though. So we know either this, so this cannot be 1, 2, or 1, 2, 3, or 4. So this is 5 through 9. That's correspondingly 9, 1, 2, 3, or 4 there, because this 5 has to see, this can't be 3 or 4 there. So it's 6 or 7. And that's a kind of a problem too. So say it goes this way. That's 1, 2, 3. This sees correspondingly 1, 2, 3, 4. So then we have boundary here, boundary here. So we have boundary there, which means that corresponds to boundary here and boundary here. This has to see at least 6 cells. So therefore it must go like that. This would then have to be 6, but then this would only see 5 cells because we already have 9 cells in the region. So it cannot go here. Which means that it does have to go this way. And that sees 4 cells. So we have a guaranteed boundary here, we have a guaranteed boundary here, so a guaranteed boundary here, and guaranteed boundary here. And this is red, so it's done. This must see at least 6 cells, so this must go that way too. This will see 3 or 4 cells. That eliminates 3 and 4 in the rest of the region. So no 3 or 4 here. It's 1, 2, 9. This is 6, 7, 8. This will see 6 or 7 cells because it doesn't see those two. So this is 6, 7 as a pair. That forces this to be 8. And that corresponds with a entropy here, which is... Oh, that... No, it has to be 1... Shoot. Technically, you could have a 1 there. Right, the only thing that's... Okay. Okay, that's not good. Well, we do know these are the opposites, because these have to see different ones. But we don't know that this is 6, 7, 8. We do know this is 1, 2, 3, 4. Oh, because... So if it's 1, 2, 3, 4... It could be 1, 2, 3 here also. Oof. Okay, so let's not make that bad assumption. This is definitely 1, 2, 3, 4 for the sum, adding up to 10. This we don't know, though. But this does have to be 6, 7, or 8 because it can't be the same digit because they seem the same number of cells. Same with this, same with this. This could be 1, 2, 3 to match the mirror, or 6, 7, 8. That's a interesting wrinkle. I was not expecting that, but yeah, you could still have that. These could be the same digits, so we don't actually have any information there. This, though, does see 3 or 4, and it must match this way because of the mirror. So this is a different digit. This is a different digit. It has... So this sees 6 or 7 guaranteed, I think. Right? It sees 6 or 7 here because this is only 8 in length, and one of these has to be 6, and one of these has to be 7. This sees 6 right now. This sees 6 right now, so one of them has to see a 7. So red is either here or here, which means this has to be a different region. So we definitely have boundary here, boundary here, boundary here. So this is boundary here, and boundary here. And this is 6, 7 as a pair, which eliminates 6, 7 in the rest of the region. This is 3 or 4 as a pair. That means this is 5, 6 as a pair here. This is 7, 8, or 9. This is 7, 8, or 9. And this must be the same entropy sets. So 6 goes with 3, 7 goes with 2. So this becomes a 2, 3 pair. That eliminates 2 and 3 in the rest of the region. So no 2, 3 there. It's 1. Remaining digits in column 9 are 5 through 9. Okay, and this can't be 5 or 6, 7. So this is 8 or 9 there. This has to be the same entropy region as 1. So it could be 1 or 8. Okay, so then the remaining digits of the red region have to be 1, 2, 8, or 9. Okay. 8 and 9 cannot be missing from the cell seen by this cell, because that's too big. 45 minus 8 is 37 at most. 9 minus 9 is 36 at most. So this is 1 or 2 here. That corresponds with, it cannot be 9 here, so it's 7 or 8 there. This can't see 5 cells, so this is 3 or 4 at most. That means this can't be 4, it's 5 or 6 at most. This 3, 4 pair eliminates 3, 4 in the rest of the column, so no 3 there. This 5, 6 pair eliminates 5 and 6 in the rest of the column, so no 6 there. Remaining digits of row 9 are 1, 2, 3, 4, 8, and 9. Okay. Oh, interesting. This always has to have a 9 here. Because the 9 must be seen by this cell. And it's not going to see the cell here, the 9 there, so it must be seen here. So that means we have to have 9 here. If it's 4, the other 2 digits must add up to 18 minus 9 minus 4, which is 5. So it would have to be 2 and 3, but this can't be 2 or 3 because it sees at least 6 cells. So this cannot be 4 here, which means this must be 3, which makes that a 4. So this sees 4 cells here. This sees 3 cells, so it's blocked here. That means this must go that way. And the digits not seen by this cell have to add up to 7, which is 1, 2, and 4. That eliminates 1 and 2 in the rest of the region, so this can't be 1, it's 8. This can't be 1, 2, or 8, it's 9, and this is 6, and that's 7. So from the same tentropy, or nitropy set, this is the region, first of all, for the mirror. Nitropy sets 6 and 3, 7 and 2, 3 and 6. That means this can't be 3, that's 4. 4 and 5. 9 and 9. And this has to be 5 and 4. And the 2 eliminates 2 here, so it's 9, which makes that 2. That leaves us as a 7-8 pair. Okay. 1, 2, 3, 4. So this has to see 4 this way. That must mean medium there. 1, 2, 3, 4. It has to be 5, 6. They have to be all part of the same region because there's only one way out. So it must go that way, which means that must go that way. And this sees 3 cells. So that's done. And this is done as a region. This is done as a region. This has to be all part of the same region because it must be symmetrical. It must exit symmetrically. So it must exit that way. This sees 3 cells, which means this is correspondingly 6 because it can't be 3 and 3 because they see the same number of cells, and this would have to have a circle in it because all possible circles are given. No more 8 here, so this is a 9. That eliminates 9 in the rest of the column. So this sees all 9 cells. So that means it has to see all of these cells. And this is not 8 or 9, it's 1 through 4. This sees only 5 cells, so this is 5 there. That eliminates 5 here, 5 here. This is correspondingly 4. So no 4 here, no 4 here. This is done as a region. Okay. 6 eliminates 6 here, so this can't be 6 and 3. This is 1, 8 as a pair. That eliminates 1, 8 in the rest of the region, so that's 3 and 6. Okay. Remaining digits of column 1. Actually, let's do row 3. It has to be 1 and 3 remaining. This can't be 3 because of 3 in the region, so that's 1, which makes that 3. 1 eliminates 1 here, so that's 8, which makes that 1. Therefore, this can't be 1 anymore. It's 8. That leaves this digit as a 6. And this cannot just see 3 cells. 6 eliminates 6 here, so that's 3. 3 eliminates 3 here, so it's 6. 3 cannot just see 3 cells, so this must extend that way. That means it extends that way there. Remaining digits of column 1, we have 5 and 7. That corresponds to 4 and 2? That can't be right. Oh, it has to be another 7 here. Oh, that makes sense. 5 and 7. And we have 4 and 7 here. Okay. That leaves the remaining digits in column 2 as 2, 6, 8, 9. Remaining digits in row 2 are 1, 2, 3, and 9. Okay. Interesting. Very interesting, actually, how this works. Sees 5. This sees at least 7. And it could see 9, but it must see symmetrical no matter what. This sees at least, can't be C4. And it cannot go down here and then down here, because then this doesn't have a region. 2, 3, 4, 5, 6, 7. So therefore it must go see one more that way, so that sees 5. And then this must be the corresponding 4 to be there. And this sees 9 cells. Remaining digits in the pink region then. This is done. We have yellow and orange remaining. Should be 18, so this is, we'll make this yellow. This must be orange. Remaining digits in the pink region. Oh, this is not 5, this is 4. We have to see 1, 2, 7, 8. So no 1 here, no 1 here, which means 1 has to be one of these 2. So one of these has to be an 8 here, because there's no corresponding 1/8 digit in this around the mirror if this is not 8. So 8 has to be one of these 2. Therefore, this must be 2 or 7. It can't see 7 there. So this must be 2. So we have to see 2 there. Oh, this could be 1, 2, 3, 4, 5, 6, 7, 8, 9. So this actually doesn't have to be different regions. Interesting. This is 2. This is 7. Oops. 7. That means it can't be 7 here. This can't be 2 here. This sees only 2, so then this is blocked as a region. This is blocked as a region. This must go that way. And it's not gonna... This can't go down here. So these have to be the same region, because if it's not the same region, this will necessarily have to block this off from here. And these are the only 2 regions left. Right, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. It has to be the same symmetrical, so if it does that, then yeah. It just can't, it can't be symmetrical and still only see 2 cells. And it couldn't see 7 cells, so that's why this is 2. So then this is all the same region, which makes this the same region here. This sees 5 cells. 1, 2, 3, 4, 5. This sees 5 cells. 1, 2, 3, 4, 5. So we have all the 5s, I think. That means this must be correspondingly 4. This must be correspondingly 4. 4 eliminates 4 there, so it's 7 and 4. 5 eliminates 5 there, so it's 7 and 5. And we have the 7s be symmetrical, which is kind of cool. Remaining digits of the orange region, we have 1, 3, 6, 8, 9. 3 can't be any of these. 6 can't be any of these. We can't have double 9s here. So 9 cannot be with its counter there. So where's 9 in the orange region? It must be there. That eliminates 9 there, which means this can't be 9 either. Where is the 7 in row 5? Can't be any of these cells. So it has to be here. That corresponds with the 2. So no 7s here, no 2s here. One of these has to be a 3 because this can't be 3, so this can't be 3 or 2, which makes that 1. That eliminates 1 in the rest of the row. 1 corresponds with 8 and not any other digit. So no more 8s here, no more 1s here. It's 3, 8 as a pair. 3, 8 eliminates 3, 8 in the rest of the column, so no 8 there. It's 7, which makes that 8. 7 corresponds to the 2, which makes that 1 there. 7 eliminates 7 here, so that's 8 and 7. 8 corresponds with 1, 7 corresponds with 2. No more 8s here. No more 2 here. No more 9 here. No more 9 here. 2 eliminates 2 here. That's fine. Okay, 5 and 4. 9 has to be somewhere on this diagonal here. Okay. We still can't have them matching the number of cells seen. But I don't think that's... I'm not seeing that right now. Remaining digits of row 8. We have to have 1, 3, 6, 8, 9 left. No 8 or 9 here because of 8 or 9 in the column. No 6 here because of 6 in the column. Remaining digits of column 8 are 1, 3, 8, 9 left. This can't be 1 or 9 because of 1 or 9 in the row. We have a 3, 8 pair in row 7. What corresponds with 3 and 8 here? It has to be 1 and 6 here. No 3 here because of 3 in the row. We have a 3, 8 pair remaining in row 7. That eliminates 3, 8 in the rest of the row. So what does that leave this? We have to have 2, 6, and 7 left. No 7 here, so we have a 2, 6 pair in row 7. That means this can't be 2 or 6. It's 7, and on the diagonal, the 2 doesn't have its counterpart anymore. So this can't be 2, it's 6, which makes this 2. 6 and 3 form of the counters there. That means this can't be 6, it's 1 and 8. This can't be 1 or 8, it's 9. 1 eliminates 1 here, so that's 6 and 1. 1 corresponds to the 8, 6 corresponds to the 3. 9 eliminates 9 here, so it's 6. This can't be 2 or 6, it's 9. That is corresponding to the 9 here. 2 corresponds to the 2 here. That leaves that as 3. 3 eliminates 3 here, so it's 1 and 3. 6 eliminates 6 here, so it's 8 and 6. And that leaves this as a 2. Yeah, I just didn't check how many cells they see. This sees 3. That's a lot of things to go through. This sees 3. This sees 5, 4, 4, 6, 5, 3, 3, 6, 4, and it matches. 4, 4, 5, 6, 4. This sees 5, and it matches. This sees 7, and it matches. This sees 5, 4. This is 5, 3, 5, 3, 4, 4, 4, and 7. 4, 2, 5, 5, 5. This matches though. 9, and it matches. 5, 4, 4, and it matches. 6, 6, 3, and it matches. 5, 7, 4, 4, 5. This is 5, 5, 5, and it matches. This is 5, 5, 4, 5, 4, 5, 5. This is 3, 4, 4, and it matches. 5, 4, 5, 5, 5, 5, and it matches. This is 5, this is 5, 5, and 5, and this is 5, and it matches. This is 2. This is 4. This is 4. This is 3, and it matches, and it adds up to 18. This adds up to 38. This adds up to 34. And this adds up to 10. This is 6, and it matches. This is 4. This is 7, and it matches. This is 4. This is 5, 5, 5, 5, and 9, and it matches. Okay, so that's good. 1 and 8 are part of the same subset. 1 and 8 so are 4 and 5. 4 and let's continue row 1, column 9. 4, 5, 7, 7, 9, 9, 6, 3, 3, 6. Let's go this way. 4, 5, 3, 6, 2 and 2, 9 and a 9, 8 and 1, 3 and 6, 4 and 5. Going row 3, column 3, 3, 6, 6, 3, 8, 1, 5, 4, 7, 2, 2, 7. Row 4, 1, 8, 2, 7, 8, 1, 5, 4, 7, 2. Rows 5, 1, 8, 6, 3, 4, 5, 7, 2. 6, 3, 5, 4, 3, 6. 8, 1, 5, 4. 8, 1. All match. Interesting. Very, very interesting rule set. The mirrored plus the nitropy mirror. The mirrored regions plus the nitropy mirror plus the circles all having all being given at the start, which means it's a negative constraint. Makes it a very interesting how it restricts things. It makes it very interesting how it restricts things, I guess. Very cool. Very interesting chaos construction rule set there. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.